In this question we're finding out the concentration of copper 2+. So copper 2+ is our analyte, and we're going to do that by performing electrolysis under controlled current. So it's controlled current coulometry. So we have a solution of copper 2+, we have 2 electrodes in there, and we're going to apply a voltage or a potential to it. So we can think of a cell here with a positive and negative electrode, and we're going to control the current, and by knowing when all the copper is used up we can find out the charge, because we know the current and we know the time. And as a controlled current it's going to be a simple kind of profile. So we need to know some way, or we need some way of figuring out when the endpoint is, when all the copper 2+ has been used up. So you would have some kind of indicator or something in there to tell you that. And you'd measure the time and keep the current constant. And we know the question tells us that it takes 90 milliamps or 0.09 amps for a total of 146 seconds. So from that we can figure out the charge transferred, the number of electrons transferred, and then how many moles of copper that relates to, that corresponds to, and then the molarity. So first of all we need to find the total charge that's being passed, and that is current times time. So 0.09 amps times 146 seconds. That gives us a total time, or total charge, of 22.14 coulombs. And we know from the Faraday constant, a Faraday constant is the charge of 1 mole of electrons. So if we take the total charge and divide it by the Faraday constant, which we can look up, is 96,487 coulombs per mole of electrons, then we can figure out how many moles of electrons have been transferred. And that ends up being 2.29 times 10 to the minus 4 moles of electrons. And we need to relate that to the moles of copper. Now we know that copper has to gain electrons, so it's going to be reduced down to copper metal. We could actually do electrogravimetry for this. We could weigh the, in this case, the cathode, or it will be the cathode. Reduction always occurs at the cathode. In this case, for electrolysis, the cathode is negatively charged. For electrochemical cell, it will be positive charged, but reduction always occurs at the cathode. And this basically tells us that there's a 1 to 2 mole ratio. So the ratio of copper ions to electrons is 1 to 2. We need the moles of copper, so we take the moles of electrons, which is 2.29 times 10 to the minus 4. And we use the ratio of 1 to 2. So there's 1 mole of copper 2+ for every 2 moles of electrons. So we're essentially dividing by 2. We get the 1.15 times 10 to the minus 4 moles of copper. And to get the concentration, we take the moles of copper and divide it by the volume, which is 0.05 liters. And we'll get the concentration of 2.29 times 10 to the minus 3 molar, or 2.3 millimolar.